Alright, this is 2.4 out of your book, Dividing Decimals, and it is page 71, so don't forget you're supposed to be following along in the book. I'll refer to some things as we go through, and here is the vocabulary for this quotient, and hopefully you remember quotient is that word that means to divide. So whenever you find the quotient of two numbers, it means you're supposed to divide those. I'm going to draw a picture for divisor and dividend. When you have a division problem like this, 24 divided by 6, actually I'll put the answer up there also. The quotient is the answer, which is that one. The divisor is the number you're dividing by, and the dividend is the number that's in the box. And I always say right here, instead of end, I always say dividend, like dividend. And that tells me it's in the box. So just one of Mr. Grimm's little stupid ways to remember those. Okay? And then compatible numbers. What happens with compatible numbers means usually when we're estimating with decimals, we want to round numbers to make our calculations easier, make the dividing easier. So if I asked you to round or to tell me, for example, I'm looking in the book right under where it has compatible numbers highlighted on page 71. It has you dividing 500. I say 500 and I wrote a 7. 574.75 divided by 11. Well, if we wanted to estimate that, we would round 11 to 10. And then we would pick a number, we would round 574 to something compatible with 10, meaning something that 10 can go into. And if you think about 570, that's pretty easy, goes in there 57 times. So it's just compatible numbers means rounding two numbers that make the calculations easier, that make them compatible. So we go through the first example. The cost of 11 tickets to see the Blue Man Group was $574.74. How much did each ticket cost? You can use long division, divide a decimal by a whole number. Divide as whole numbers, then line up the decimal points in the quotient and the dividend. So here is a situation where we are dividing, and you have 574. That's a lot of money, isn't it, for 11 tickets? $574.75 divided by 11. You divide, it's saying you just divide like normal. I just make sure you take this decimal. First thing I do is bring it straight up. And when you divide, it's very important that you line up your numbers so you don't leave anything out or get out of line. So you take 11 into 57, and 11s are easy. It's 55. And you subtract, you get 24, bring it down. 11 goes into 24 two times, which is 22. Subtract again, bring the 7 down. 11 goes into 27 two times, which is 22. And then there would be a 5, bring the 5 down, and it goes in there exact. So your tickets cost $52.25. And if I remember right, Blue Man Group, that's like it started on Broadway. It was a big show, like if you were going to go down to Denver to the Buell Theater or someplace like that. So there's our dividing. So let's see what they do. Divide is just as you would with whole numbers, just like we did. There they go. Just like we did. And the only thing I noticed different is they just do the decimal point as they come to it. I bring it straight up and then divide so I don't forget it in my answer. And you stop dividing when you have non-zeros. So let's do this. Find the quotient, then check your answers. So we go to 20.1 is the dividend, it goes in the box. The 3 is the divisor, it goes on the outside. I'm going to bring my decimal straight up. 3 goes into 26 times, which is 18. Subtract, bring down the 1. 3 goes into 21 7 times. So the answer is 6.7. Check my answer. One way to check it is to just kind of round. 6.7 is almost 7. 7 times 3 is 21, and it's a little less since we rounded up, so then it would work. Or to check division, you could always do 6.7 times 3, and then you should get the answer that was the number that was your dividend. So that's a good way to check division, is to multiply. So we go 64.35 divided by 5, bringing that up. 5 goes into 6 once. 5 goes into 14 twice. Bring down the 3. 5 goes into 43 8 times, which is 40. That's 3. Bring down the 5, and it goes in there 7. 12.87, and that's it. And then again, you could multiply to check your answer. Let's just round to check ours. That was almost 13. 13 times 5 is 65, and that's really close. Getting longer on us, aren't they? Here, let me erase so I can have more room. So 380.32 divided by 4. Bring my decimal straight up. 4 goes into 38. Let's see, 8 9 times, which is 36. 4 goes into 25 times, which is 20 exact. Bring the 3 down. 4 doesn't go into 3, so you have to put a 0 above it. Then bring the 2 down, and it goes in there 8 times. So 95.08. Example 2, dividing decimals. You'll notice in these problems some of these you're dividing a decimal by a decimal. So when you see A, when we start to write A out, that's 3.804 divided by 3.17. You can never divide as a decimal on the divisor. So I remember this little saying, over, over, and up. What you're referring to is what you're doing with the decimal. So you start on the divisor side and you go over until it hits the division bar. So that would mean to move the decimal 2 places. So that's the first over, is how far you move the decimal over to the bar. Then the second over is you have to move the decimal inside the same amount you moved it on the outside. So 2 there, and then straight up. Then you just pretend like those decimals were never there, and you just divide. 317 into 380 goes once, which would be 317, and you would subtract, and then you bring the 4 down. Then 317 goes in there, I'm going to say twice because I think it's going to come out exact. It's going to be 3 and that's going to be 6. It is. So that'd be 634, and you can stop when you get 0 there. If we wouldn't have gotten a 0, we would have had to add a 0 up here, so we could have brought it down. Okay? That's over, over, and up, and you use that when you have a decimal as a divisor. Now let's see if they do these all at once, or if they move them. They're talking about multiplying it. That's the same thing as doing over, over, and up. I just think it's easier. And they're doing work. I'm just looking at 0. Yep. Okay, so let's do the second example. 8 divided by 1.6. So 8 goes in the box. 1.6 goes on the outside. Okay, so we can't have a decimal here. There's our first over. We move this one over 1. Decimal on 8 is right here. We move it over 1. And then we bring the decimal straight up. So 16 into 80. Since 80 ends in a 0, I'm going to try 5. And it's going to work. If I can get my pen to work. So 16 goes into 80 5 times, or 1.6 goes into 8. 8 divided by 1.6 is 8. So they did the same thing, noticed? Got the same. Oh, shoot. It's 5. Oh, yeah, I must need to stop doing this. Yes, look, I had 5 right here. What was I thinking? Hopefully you were yelling at me that I messed up. Alright, so this one would be 0.114 in the box. First number written is the one that's getting split up. 1.9 on the outside. Over, over, and up. Okay. 19 won't go into 1. 19 won't go into 11. We have to take 19 into 114. So we try 6. Let's see, that's 54. Carry the 5. 114. Look at that. Came out just perfect, like I knew the answer or something. So they're going to show moving the decimals just like we did. And there's the 0.06. Same answer that we got. Okay, so here's a guided practice. You're writing, and you know that's why it's called long division, is because it's a little bit long. So just start writing. So the 110.85 goes in the box, 1.5 goes on the outside. So we're going to go over, over and up. And 15 won't go into 11, so we have to take 15 into 110. That's 90. 15 times 7 is 105. So we're going to put 7 right there, 105. Subtract, we get 5, bring down the 8. 15 into 58, well 15 times 4 is 60, so it's going to have to be 3, which is 45. See how it just helps to know your facts. And if 7 is 105, we add 2 more 15s to make 30. So let's try 15 times 9. $135, so it's 9, which is 135, and that's a 0. 73.9. There it is, just step by step. All the arithmetic, all the operations that we've learned are in there. So let me erase all that stuff. So we go 0.234 divided by 0.3. So we go over, over and up. 3 won't go into 2, but 3 goes into 23 7 times, which is 21. 24, and 3 goes into 24 8 times. These are nice. They're coming out nice and neat for us. We're not having to do anything with those. This one's pretty easy because I see some basic facts in this one. Hang on, I lost my pen. Where are you? There it is. Okay, so 9 goes in the box, 0.3 on the outside. The only thing I got to do is move the decimal. So 3 goes into 9, 3. So 0.3 goes into 9 30 times. Another way to look at it is like money, because I like to look. This is like 30 cents. How many 30 cents are in $9? And it would take 30 of them. So another way to look at it. 0.208 divided by 5.2 over, over and up. 52 won't go into 2, it won't go into 20. It's got to go into 208. I'm going to say 4 times. Look at that. 4. Ooh. I don't know how I get that line to go like that. If I tried to do it, I couldn't get it. Let's see if it works. It does. I wanted to back you guys up here on your notes, page 72. I've told you to add in the key concepts. There is a key concept on page 72 which talks about, in their words, it talks about the over, over, and up. It says when you divide a decimal, multiply both, and I'm on page 72 in the key concept box. When you divide by a decimal, multiply both the divisor and the dividend by a power of 10 that will make the divisor a whole number. Well, when I'm moving my decimal over, that's the same thing. So that, in other words, in that key concept, you can put the concept over, over, and up. And you'll notice that's what they do on the example with the numbers. Okay? Example 3, you buy a pack of 8 collector cards for $2.15. Use a verbal model to find the price of each card and round to the nearest cent. Okay, so 8, this is your total cost. So if you take your total cost and divide it by the number of cards, that's going to equal the price per card. Okay, so the total cost is $2.15, and we need to divide that by the number of cards you got, 21 goes into 8 2 times, which is 16. 8 goes into 55, 7, ooh, almost 7, 6 times, which is 48. Okay. Subtract, that's going to be 7. Add another 0 because it wants us to round to the nearest cent. That's the hundredths place, so we got to go out 3 places then, and that's going to go in there 8 times. So that's going to round to about 27 cents per card. And there's the same thing, rounded it to the nearest cent, 27 cents. Okay, so on this one, the guided practice, it says, in example 3, suppose there were 12 cards in the pack. Find the price of each card. Well, instead of taking $2.15, so we're going to still take the $2.15, but this time we're going to divide that by 12. So bring our decimal up, 12 goes into 21 once, which is 95. 12 goes into 95 about 7 times, which is 84. There's 11. That goes in there. 12 goes into 110. About 9. So it's going to be about 18 cents if there's 12 in a pack. So that's it. I think we got that one right. I'm not sure where that one went. Anyway, that's the guided practice for 2.4. Yeah, 2.4. So we'll see you next time.